My name is Kelly Heaton. I'm an artist who's really interested in electricity. When I went to college at Yale, I started as an art major and got disenchanted with it because the focus was very much on traditional media and I needed something more. At the time, I didn't have a language for what I needed. But what the thought process was going through my mind is that I was really interested in systems. So I wanted to understand the relationship between things, but on a meta scale. And I had no background in science. In fact, if you remember, and I guess this exists still today, but there's very much like you were either a liberal arts person or you were a science person. There was no real crossover between those two camps. And I very much identified with being a liberal arts person. So yeah, I went through a period of confusion there for a while. I ended up defining my own major as an undergraduate, environmental management in the urban context, which was essentially like, let's look at ecology and culture and political science and figure out how they all intersect. But for me, that was a system, and I loved that. I'm not interested in just making something that simulates life. What I'm interested in is exploring, like, what are the bare fundamentals of how electricity can be transformed as a creative and become something that has lifelike qualities. The point being that with just these small elements, I'm able to create vibrations of electricity that have emergent behaviors that were like, whoa, that seems kind of like a bird song. So in my circuit design, the element that I'm working with consistently, like the core element that I'm looking at, is vibration. So I build a type of circuit that is called an astable multivibrator, and it just vibrates. It just does this. Sometimes, depending upon the components I choose, it's either a symmetrical vibration or it can, vibrate asymmetrically. But it's a really simple thing to do. So I take these vibrating elements, oscillating elements, and I couple them together using typically capacitors, so they affect each other, right? And then I look at how many discrete vibrating circuit elements do I need to link together in order to get a resulting signal that has interesting properties. And it turns out, and when you see the bird sculpture that I brought to demonstrate for you, I have 5 oscillators that are connected together in a very simple way. Like everything that's happening is happening right here on the circuit. And I'm not saying at all that it's just like a bird. I mean, that's not the point, right? The point is that it's very bird-like, and it's wild. The value of art and science, scientists can't make things like that, right? Engineers can't make things like that. I mean, who's going to pay their, you know what I'm saying? Like they don't have that kind of creative liberty. We need to expose ourselves to other ways of thinking, and we need to be aware of different issues. A frontier in science where art can tremendously contribute is an understanding of navigating the grayscale space. These people who are managing the oil and vinegar engineer and artist, or however you want to look at that, they're constantly, they're almost like creating an environment where things are just destined to go wrong, and out of those errors, new discovery is happening.